Hello everyone. Today I am discussing the problems related to differential equations which carries 5 marks in part D. Any equation of this form, those equations are called as linear differential equation. Okay. So observe this properly. The given question dy by dx. Yes, we are having in the place of dy by dx as it is dy by dx. Py. See why we are having in the place of p we are having secant x. In the place of q we are having tan x. See this is what actually in a linear differential equation. Okay, so the given question, let us solve this linear differential equation. This is a very simple problem actually. Easily you can score 5 marks. This is for 5 marks. Okay, so easily you can score 5 marks. Let us see how to solve this problem. So first let me write the question dy by dx plus y into secant x is equals to tan x. Compare with, let me compare with dy by dx plus py is equals to q. So in the place of p, we are having secant x. In the place of q, we are having tan x. See, if you have got p and q value, then we should find out the integrating factor, IF, integrating factor. There is a formula to find the integrating factor. What is that? E to the power of integral of p into dx. Just substitute the value of p. P is what? Secant x into dx. So we know secant x integration is log of secant x plus tan x. Log of secant x plus tan x. See, e to the power log, it will vanish. Only secant x plus tan x will remain. So this is what actually integrating factor. See, what you should do? First thing, you should compare the given equation with the standard equation of linear differential equation. After that, identify P and Q and then find out the integrating factor. After finding the integrating factor, we should write the solution. Very simple. Solution is y into integrating factor is equals to integral of Q into integrating factor with respect to x. This is the solution. Just substitute Q as well as integrating factor. Keep this y as it is. The integrating factor is secant x plus tan x is equals to integral of q. What is q? Tan x. Tan x into integrating factor is secant x plus tan x into dx plus c. So even here also I should write plus c. Now let me integrate the right hand side by multiplying tan x inside the bracket. Secant x tan x plus tan square x into dx plus c. Now see here, we should integrate this. We know integration of secant x into tan x, but we don't know integral of tan square x. So that's why what we can do, let me do here, integral of secant x tan x, I will keep that as it is. Plus tan square x can also be written as secant square x minus 1. Now directly we can integrate everything. So secant x into tan x integration is secant x plus secant square x integration is tan x minus 1 integration is x plus c. So in the left hand side what we are having? Y into secant x plus tan x we are having, that is equal to secant x plus, I will write down this in the next line, secant x plus tan x minus x plus c. That's all. See, this carries 5 marks. Actually, comparing the comparison till here 1 mark, finding the integrating factor 2 marks, writing the solution 3 marks, and integrating and writing the final answer 5 marks. Okay, this is a compulsory question for 5 marks. Easily you can score 5 marks. Let us move to the second question. Find the general solution of the differential equation x into dy by dx plus 2y is equal to x square. Let us find the general solution. Even this is also linear differential equation. So as you know already, we must compare this with the general equation, that is general solution or the general equation, linear equation. Okay. So first, I will write down the problem x into dy by dx plus 2y is equal to x square. Let me compare with what? The general linear differential equation. Compare with dy by dx plus py is equal to q. Observe this properly. Only dy by dx we must have, but we don't have sorry, we are having dy by dx along with x. So we should convert this into the standard form. To compare that, what we can do, we don't want this x here. Whatever x we are having has a coefficient of dy by d. We don't want this x. So what we can do? Divide the whole equation by x. Okay. So let me do that. I will consider this as equation 1. Okay. So let me do this. Divide divide equation 1 by x. So if you divide by x, what you will get? In the first term, x will get cancelled. Plus 2 by x into y is equal to only x will remain, because if you are dividing by x, one x will get cancelled. Okay. In the second term, it won't get cancelled. So that's why I have written that as 2 by x. So here, what is P? P is equal to 2 by x. Q is equal to x. Now, what we should do? We should find out the integrating factor. Integrating factor is equal to e to the power of integral of P with respect to x. What is P? Integral of 2 by x into dx. You know 1 by x? 1 by x integration is, see, actually 2 is a constant. Integral of 1 by x into dx. So 1 by x integration is log x. So 2 log x. This is in the form of m log n. So that can be written as log of n power m. That can be written as e to the power of log of x square. Okay. See, e power log, it will vanish, as you know. Only x square we get. X square, what you have got, that itself is the integrating factor. Okay. See, till integrating factor we have got. What we should do further? We should write the solution. Okay. The solution is, the solution is y into integrating factor is equal to integral of q into integrating factor with respect to x plus c. Why? As it is, I will write down what the integrating factor, that is x square, is equal to integral of q. Q is x into integrating factor is x square with respect to x plus c. So as it is, you write that left hand side. The right hand side, x into x square, it becomes x cube. X cube with respect to x plus c. So now y into x square, x cube integration is x power 4 by 4 plus c. Okay. So I think you have got this. Now, if you want, you can simplify this further, or else you can keep this as it is. Okay. So this is the final answer for the given linear differential equation. This is the general solution of the differential equation. I think you have got this. The third question is, solve the differential equation cos square x into dy by dx plus y is equals to tan x. See, even this is also linear differential equation. Obviously, already you know, in linear differential equation, that is 5 marks question, compulsory one problem will be there in the final exam. So let us solve the given problem, that is the third question. So let me write the problem first. The problem is cos square x into dy by dx plus y is equals to tan x. So see here, we want only dy by dx, isn't it? We are having cos square x also. So that's why divide the whole equation by cos square x. Then let us see what we will get. It will get cancelled the first term, isn't it? So only dy by dx will remain here. Plus 1 by cos square x, 1 by cos square x into y is equals to tan x by cos square x. Now see here, dy by dx. Let me simplify this further again. 1 by cos square x, we can write that as secant square x into y. And then tan x. Tan x can be taken as sin x by cos x whole divided by cos square x. So see, what it becomes actually, tan x is sin x by cos x. Okay. So 1 by cos square x, that whole divided by cos square x. Cos square x means divided by 1 we are having. So this 1 goes to numerator, cos square x comes to the denominator, then it becomes, or else even if it is somewhat confusing, see, even you can write this as 1 by cos square x is what? Secant square x. Even in that method also you can write. Okay, don't get confused. Instead of that, I will write like this, tan x into secant square x. See, now let me compare with the general. linear differential equation. Okay, compare with dy by dx plus py is equal to q. So in the place of p we are having secant square x. In the place of q we are having tan x into secant square x. Let me find out the integrating factor, that is e to the power of integral of p with respect to x. So e to the power of integral of p is secant square x into dx. So secant square x integration, as you know, that is tan x. So we got the integrating factor has e to the power of tan x. Now therefore the solution is, I will write the solution. Okay, therefore the solution is y into integrating factor is equal to integral of q into integrating factor with respect to x plus c. This is the solution. Okay, now substitute everything. Y as it is, you should write integrating factor is what? E to the power of tan x is equal to integral of q. Q is what? Tan x into secant square x into integrating factor is e to the power of tan x into dx plus c. Now we should integrate this. We should solve this, isn't it? So now see here, we can't integrate this whole term. That's why we must apply some methods of integration. What method we can apply here? See, tan x is there, secant square x is there, e to the power of tan x. There are three terms, isn't it? But we know tan x derivative is secant square x. So that's why we can apply the substitution method by taking put tan x is equals to t. Differentiate with respect to x. Tan x derivative is secant square x into dx is equal to dt. So when you apply this in the given problem, there what it becomes? Tan x. Tan x, I will replace it as t. Okay, secant square x into dx can be taken as dt, e to the power of t into dt plus c. See, we have got product of two functions, isn't it? So, if you have got product of two function, we must apply the what? Integration by parts. Okay. So, integration by parts means since we are having product of two function, obviously we must apply integration by parts. So, which will decrease after differentiating, that you should take it as a first function. So, see here, actually t, it will decrease, isn't it, after differentiating. So, I will take this as a first function and this as a second function. Let me apply the integration by parts. First function into integral of second function. E power t integration is e power t minus integral of e power t, integral of e power t into derivative of first function with respect to t plus c. So t into e power t minus e power t integration is e power t plus c. Substitute the t value, tan x into e to the power of tan x minus e to the power of tan x plus c. Even in left hand side, we are having e to the power of tan x, isn't it? So what we can do? We can divide the whole equation by e power tan x. Then it becomes what? Y is equals to tan x minus 1 plus c by e power tan x. So this is what the final answer. Okay, I think you have got this answer. If you have any doubts, you please put in the comment box. Okay, I will move to the fourth question. Find the general solution of the differential equation x into dy by dx plus 2y is equals to x square log x. So let us first, what we should do actually, first we should convert it into standard form of linear differential equation, isn't it? So x into dy by dx plus 2y is equal to x square log x. This is what the question. So to get into the standard linear differential equation, we don't want this x here, so divide by x, divide the whole equation by x. Then let us see what we will get. X means the first term, in the first term x will get cancelled, only dy by dx will be remaining, plus 2 by x, it becomes same as the previous problem. One x will get cancelled, another one x will be remaining. Okay, now this is in the, let me compare this with the general equation of linear differential equation. Compare with dy by dx plus py is equal to q. So let me compare. See there, in the place of p we are having 2 by x. In the place of q we are having x into log x. So now what we should do, first thing we should find out the integrating factor. Integrating factor is e to the power of integral of p with respect to x. That is, e power integral of p means what? 2 by x into dx. 2 by x means 2, it is a constant, keep that outside the integral. 1 by x dx, as you know, 1 by x integration is e to the power of 2 log x. 2 log x means it is in the form of n log m, that can be written as log of x square. So e power log, it will vanish. Integrating factor, we have got it as x square. Therefore, let me write the solution of this question. The solution is y into integrating factor is equal to integral of q into integrating factor with respect to x plus c. So y, as it is, you write down y. Integrating factor is x square is equals to integral of q. What is q? X log x into integrating factor is x square with respect to x plus c. So let me simplify this further before integrating. Log x, I will keep this as it is. X into x square, it is x cube with respect to x plus c. So now, see, to integrate this term, we must apply integration by parts because it is product of two functions, isn't it? I will apply integration by parts by taking log x as first function and x cube as a second function, because we don't know the integration of log x. We know the derivative of log x. Okay, so that's why I will write the left hand side as it is. So integration by parts, I'm applying first function into integral of x cube is x power 4 by 4 minus integral of second, as you have done there, write that as it is, x power 4 by 4 into integral derivative of log x is 1 by x into dx plus c. See, 1x will get cancelled here. Write down the remaining terms, that is x power 4 log x by 4 minus 1 by 4, I will keep outside the integral. The remaining is x cube with respect to x plus c. So now let me simplify further. X power 4 log x divided by 4 minus x cube. X cube integration is x power 4. X power 4 by 4 4s are 16 plus c. So this is what actually the required differential equation. Okay. So if you don't want this x square in the left hand side, you can take it to the right hand side. If you take that to the right hand side, what it becomes? X square log x by 4 minus x square by 16 plus c by x square. This will be the final answer. Okay. I think you have got this question. If you have any doubts, you can put in the comment box. Let us move to the fifth question. X log x into dy by dx plus y is equals to 2 by x log x. So see there, actually in this question, this is not in the standard form, isn't it? So let me convert it into standard form. So we don't want this x log x. Let us write the problem first. X into log x into dy by dx plus y is equals to 2 by x into log x. So what we don't want here, x log x. So divide the whole equation by x log x. Okay. So if you divide it by x log x, what you will get? You will get the first term only dy by dx plus the second term is 1 by x log x into y is equal to 2 by x square. See, log x, it will get cancelled, only 2 by x square will remain. So if you compare this with the linear differential equation, compare with what? Dy by dx plus py is equal to q. So in the place of p, we are having 1 by x log x. In the place of q, in the place of q, we are having 2 by x square. Okay. So now let me find out the integrating factor, that is equal e power integral of 1, p into dx, p with respect to x. So e power integral of p is 1 by x log x into dx. See, actually 1 by x log x, this is, we should integrate this. So how you will integrate? Directly we can't integrate. We must apply some substitution even here. So what substitution we can take? Put log x equals to t, because as we don't know the integration of log x, let's take that has t. Log x equal to t. Differentiate this with respect to x. If you differentiate with respect to x, what it becomes? 1 by x into dx is equal to dt. So the given problem can also be written as e to the power of integral of, see, 1 by x dx, we can replace that as dt. 1 by log x can be replaced as 1 by t dt. 1 by t integration, as you know, that is log t e to the power of log t. So that is equal to t. E power log, it will vanish, only t will remain. T is what? Log x. So this itself is the integrating factor. So now let us find out the solution. Therefore the solution is, I will write the solution here, y into integrating factor equals integral of q into integrating factor with respect to x plus c. So the integrating factor is log x. Keep that as it is. Integral of q. Q is what? 2 by x square into integrating factor is log x into dx plus c. Okay. So now see here, we are having a constant, that means product of two function. As you know, we must apply the integration by parts. Before applying integration by parts, I will take the constant outside the integral and I will shift this x square to numerator. So if you take this to numerator, the power becomes negative. So see here, what I will write here, log x into x to the power of minus 2 with respect to x plus c. So now what I will do here, I will consider the log x, this has a first function and x power minus 2 has a second function. Now I apply the integration by parts. So 2 into first function into integral of x power minus 2 is x power minus 1 by minus 1 minus integral of x power minus 1 by minus 1 into log x integration is 1 by x with respect to x plus c. Now see there, actually what we should do there, I will simplify this term. Okay, x power minus 1 means if you take it to denominator, it becomes positive, isn't it? So minus log x by x, minus into minus, it becomes plus. Integral of 1 by x, already 1 by x is there. If you take this to 1 by denominator, even it becomes 1 by x. 1 by x into 1 by x is 1 by x square into dx plus c. Okay, so now the finally, if you integrate this, what we will get? Minus log x by x plus x power minus 2. X power minus 2 integration is x power minus 1 by minus 1 plus c. So after simplifying further, I will take this 2 inside. If you take this 2 inside, it becomes minus 2 log x by x minus 2 by x plus c. What is there in the left hand side? Y into log x. So this is what actually the final answer for the given differential equation. If you have any doubts regarding this, you please put in the comment box. If you have understood this question, please subscribe my channel, like my channel and share my channel. Thank you.